So this is actually the same day as the previous video, but because of movie magic, you don't know that, so pretend you don't know that. May as well just talk about more of the books. Let's get into it. So, first off, what's on the shelf here? Oh, secret envelope? Huh. Well, who knows what's in there? My secret spy instructions. Whoa, 57 dimension. We're the only composite prime. Yeah, I haven't really looked at this book because, well, okay, I don't want to be like too pretentious. I don't know everything that's in here. There's cool stuff. I've opened up this book before and I've looked inside. There's interesting things. But it's maybe more of a pop math kind of thing. But it's nice, it's pretty, and there is cool things. But I really just inherited this because it's in the office. Maybe I should look at it more. There's more cool, interesting things. But okay, that's not even like really a textbook. Let's keep going. Does this count? Does random sets of notes on characteristic classes that have sitting around, like printed off paper notes, count? Not really, because I don't think you can. No one can get those. So let's talk about representations of compact Lie groups. Yeah, there's going to be, actually, I promised that today there would be more books I've actually read, but that's a little bit of a lie. Yeah, so, I mean, I've read some stuff about complex, but again, this has just been, I've never gone through this thing carefully. It's, I've taken it for granted. I've learned things about the complex, the representations of compact groups other places, but Tanaka-Krein duality, I should talk about that sometime soon. It's freaky, it's cool. Root systems, yeah, because they're Lie groups. Of course, we're going to talk about root systems. Okay, not that much to say about this, to be honest. But probably a book, maybe I'll try and teach out of this book one day. Teaching's the best way to learn about a subject, not actually knowing it. But now, here's a book that I've been through a bit. Introduction to Lie Algebras and Representation Theory by Humphreys. So I mentioned this on stream the other day. This is maybe a good second book or something for Lie theory, because it does everything sort of in over an arbitrary field as opposed to like the complex numbers or something. But so basic notions about Lie algebras, but yeah, everything's just over like a general field. The theory works pretty much the same, so actually it's not so bad to jump into this immediately, but I don't know, I think it was helpful for me psychologically to maybe see stuff in the real and complex case first, explicitly working out things about root systems, isomorphism and conjugacy theorem, so very important stuff. I was talking about, I think, the office hours on the 18th, maybe. Was I talking about it there? Oh, no, I talked about it in the last video, that was in the book on affine group schemes, right? Talking about classifying things over root systems. So here we actually get proofs of that stuff, which I don't think we do in the affine group schemes, like the existence theorem. Probably the uniqueness theorem is somewhere in here as well. So yeah, definitely a classic book to have if you're doing anything with Lie groups or just like algebraic groups in general. A book worth having. Now, let's look at these rare gems. So, which one? Interim report. Yeah, there's these two things. So, I should make a video on this too one day. So here's some old papers with like hand crunched tables. So this is Richard Guy very famous combinatorist mathematician who is no longer with us, but he was at the University of Calgary when he was still on this earth. And these are some papers about Aliquot sequences, which is basically like you take the sum of divisors function and you just repeatedly apply it. Or I would go 1/2 the sum of divisors, right? So the 1/2 sum of divisors is what is like a perfect number is equal to 1/2 of the sum of its divisors, like 6, for example. Or sorry, not 1/2. You subtract out the number itself. That's what it is. Yeah. So it's like sigma n minus n. Number is perfect if sigma n is equal to 2n. Oh, so you do divide. You do divide. It's the same thing. I'm silly. Anyways, I played around with some code with I'm promise I'm not doing crank math, but every mathematician has got to work on some unsolved problem in a very naive way from time to time. And I made some graphs, which maybe I'll share sometime. In Sage, I wrote some programs that graph like the highest number you hit or how many numbers you hit before like you hit the cycle. I did this for Collatz and Aliquot. Not that these are related to each other at all. But I came to the conclusion that answering questions about the termination of Aliquot sequences is way harder than Collatz. This is a purely vibes-based speculation based off how chaotic the graphs looked. Anyways, I did that all before I got to Calgary, and I found there's some certain numbers that just are like the program craps out because it won't compute all the steps, and so I had to like manually put in exceptions to these. And how I know what some of those numbers are from these papers by Richard Guy, and then they just happen to be giving away. Oh, you see, we've got these nice charts of different Aliquot sums feeding into each other. Oh, this looks crazy. I need to take a closer look at this. There's some crazy stuff going on here. Fascinating stuff. So I grabbed those, of course. Now we're probably going to. We're coming to the foundational texts of my field. This is like my Bible, basically. Automorphic forms, representations, and L functions, parts 1 and 2. This is it. This is like the foundations of classical Langlands. I mean, everything's all fancy and moduli stack a bungee or whatever these days, but this goes back right to the beginning, and certainly part 2 I've spent some time with. Just look at the names here. It's all the biggest names: Springer, Titz, Naps, Shellstad, Cartier, Lustig. I mean, these are all some of the biggest names in the field. Flath, of course, Langlands, Howe, Arthur, my mathematical grandfather, Piatetsky, Shapiro. I mean, okay, I'm just listing literally everyone that's in here, right? So, but part 1 is about setting up some of the theory, right? So just general stuff about there's this great survey, say, by Cartier about representations of p-adic groups. That's a good like classical introduction. Though maybe these days, Getz and Hans, like that's what I'd recommend anyone read. But so there's stuff about reductive groups, orbital integrals, supercuspal representations, automorphic stuff, theta series, trace formula, all classic stuff. Worked out L functions in certain case. All super important stuff. Schirmer varieties and motives by Langland. So you've got like everything in here and more. And then part 2 is probably what I've spent more time with. It's definitely a bigger book. Let's see, does it have its own separate table of contents? Oh no, this is part of the same table of contents. But Yeah, I would say part two, probably the article I've spent the most time looking at. Well, definitely Cartier's survey on p-adic groups, but Burrell's thing about automorphic functions. I guess a bit of Tate's number theory background, but Burrell's automorphic function. So this is, probably one of the. I'm sure that these things were constructed in like previous papers, but this is like a great sort of classic reference of talking about like the L group and the construction of like Langland's parameters and connecting those to semi-simple conjugacy classes, like all of that classic stuff. Yeah, so these are highly valued. Probably some of the most important books for me in my collection. So yeah, these are. Where did these take place? The symposium took place. Where was it? Because sometimes these are just referred to by the location of this conference. I can't remember what it was. These came out of like this one big meeting. I can't remember what it was. But anyways, it was like an important meeting of all of these brilliant minds in the field. So let me just grab the rest of this stack here. Speaking of stacks, in a very different sense. Okay. What else we got? We gotta get through this pile today. So I got Global Calculus. Also a book. This is just a book I've looked at, sort of for fun. I haven't studied it seriously yet, but it was some free giveaway book. So it's another one when I just sort of get tired of stuff I'm supposed to be doing. I flip it open and just look at the pretty symbols. I mean, some of the stuff is things I know about, sheaves, maybe differential operators I'm not as experienced with, but like definitely, integration on manifolds, these sorts of things. And basic stuff about cohomology of sheaves. Probably this later stuff. I don't know. Well, I've done some Chern-Weil theory, but I don't know what they're talking about exactly with lifting of symbols, elliptic operators. So that's maybe a section I'd like to read a bit more. I've flipped through some of these things: Hodge decomposition, Lefschetz. I mean, technically, that's some of these things are like important in the background of things like perverse sheaves, like they're swimming there, but I've never really needed to dig into those. But they're famous theorems, they're beloved theorems by many people. Should probably check it out someday. I don't even know what this is. Oh yeah, so this is someone's thesis that was here, also about Aliquot sequences and series. So one day I'd love to go back and revisit my code, maybe see if I can prove some things about Aliquot sequences. But you gotta love this old, like back in the day, probably took a long time to have the computer do these computations, and you used to list them in a book like this. Fantastic stuff. Oh yeah, here's a great tree of things flowing into the perfect number, 8,128. What's that, like the fourth perfect number or something? Awesome stuff. Okay, more untouched goodies. So it says Introduction to Quantum Field Theory, something I'd like to learn more one day, but also, so obviously someone just printed off this textbook, but it starts at chapter 4. And I took a course in my undergrad about Feynman diagrams, so I know a little bit about that stuff, but it's been a while, and probably since the first 3 chapters are missing, I don't know when I'm going to get to that. This one I think has all the chapters. Yeah, so this is gauge theories, strong, weak electromagnetic interactions. Definitely something. Yeah, again, I grabbed it because it was free, printed off. Something to read one day, but this is so far from my research. That's like for my retirement or something. Yeah, here's one where I've read the sequel more, but this is a first. This is a good first introduction. Rational points on elliptic curves. What do we got in here? So, yeah, I mean, actually, I haven't studied height functions in any great generality, but yeah, this is. Oh, I like that they have computer packages in here. You know, classic. This is a classic book on some more down to earth, more suitable for undergrads. Is the version of elliptic curves covered here. There's even this appendix on projective geometry, which is nice. I'm kind of surprised. Maybe I knew this at one point, but I'm surprised I get into theory of complex multiplication here. It's not just multiplication of complex numbers, but it's an important thing at the intersection of like number theory and elliptic curves. Well, okay, elliptic curves are number theory, but yeah, I thought that was more of an advanced topic, but I guess they cover it here, so that's good to know. Of course, any good book on elliptic curves will start with the inspiration from Fermat's last theorem. Naturally, how could you how could you not mention that in the introduction to your elliptic curves book? Constructive analysis, definitely something. So I've probably talked a little bit about law of excluded middle and constructive mathematics on this channel before. It's not so clear to me that this book is strictly about doing everything without the law of excluded middle, but as it sort of suggests, it's like by an algorithm or an effective algorithm. So definitely towards that spirit of constructivism. Again, not something I've really had the time and motivation, but I really would like to understand parts of this book better. It's been just another sort of casual read, flipping to random things, but maybe worth checking out eventually. And then the final one for today's video would be another one. I don't think I've even opened this, let's be honest. Mumford's Algebraic Geometry 1. Yeah, again, I learned algebraic geometry from different places that weren't this book. This book has sort of come into my life more recently, but maybe I would use it for reference at some point. I mean, they talk Chow's theorem and Chow theory, so I've had to pick up pieces of that from different places before. So maybe this would be a good way to go relearn that. There's places in my life where I could definitely make use of Chow theory more. So that was basically it for today. Okay, maybe it wasn't as exciting of a review as I promised in the last video, but hopefully, I did cover the absolute Bibles of my field today. So I hope you're satisfied with that, because those are the most important books in my collection. And that'll do it for now. I think I've maybe got one more episode to do, which I actually will record on a different day, for the rest of the books in the office. And then, which also, to be honest, there's a lot of those I haven't read super in depth. But then we'll be back home, and we'll dive into more of those books that are on my shelf.